Well, in today's video, I will be explaining about database. What is a database? You ask yourself, what is a database? So, you use databases every single day when you check Instagram, order food online, even when you send a text message. But what exactly is a database? So I'll be explaining this with something you already understand. So in this video, I'll explain database using something we call a cabinet analogy. Okay, this is now what you call cabinet analogy. Yeah, so think of a database like a digital filing cabinet. Okay, in a real office setup, you have filing cabinets with drawers. Each drawers folders, and each folders documents with information. Okay, so in our office we have something like this, whereby we have a drawer or what you call a cabinet with different drawers. This is drawer 1, drawer 2, 3, 4, 5, 6. Okay, something of that sort. And then this drawer, maybe you're storing something like customers files. You're storing something else here in this drawer, like employers, employees, information. In the other drawer, you're storing other information about the company, the project that you've done, and all that. Either this one is financial record and all that. Okay. So a database works exactly the same way, except that now instead of paper, everything is stored digitally. Okay. Yeah. In database language, each drawer now we call them a table. Okay. We have different databases that we use. We have relational databases, relational and non-relational. Relational databases. But in this video, I'll focus more on relational databases, where we have something like SQL. We have something else like Postgres SQL. These are relational databases, but I will not go deep into each database, but I will be explaining using something just simple tables that it will help you now understand everything that I'm talking about. Yeah, so let me draw a customer table. Let's say we have a record here for customers. I'll draw a customers table. Let me call this, sorry, this something of that sort, and then so this is ID. We have name, we have phone, we have now something like email. So this is customers table. Just explaining this in maybe for a certain e-commerce website, maybe you're working on, or a web application, and you have customers table, we have orders table, and all that. So I'll be explaining all that, but you start with the customers table. At this point now we have an ID. This is now the unique identifier for that record. Now these columns here, ID, name, phone number, these are what we call now fields. Okay, they tell us what type of information we are storing. Okay, yeah, so let me have at this point we have John, which is name now, phone number 076. Just think of any phone number. This is Gmail. Okay, so this one now forms now one record. Okay, then we can have another record here. We can have Lucy. This is the Lucy gmail.com. So this is one record, this is another record. So in this table, the customers table, we have 2 records, okay, for John and Lucy. These are other data that are related to this specific record, okay. Yeah, so each row here is now a customer. This is one customer, this is another customer, and this is one complete record. So as you have said that this table has 2 customers right now. So see how each row is 1 person. That's a key. That each row is now complete set of information about one thing. Okay. In this case, one customer. If I have 1,000 customers, these tables now will have 1,000 rows. Simple as that. So you can have as many records as you have, as you want. For your table. Then we can have I think I will have to draw another table here for orders table. Now this is orders table. We can have something like something of that sort. We have ID. This you can either call it ID or something like order ID, and then you can have customer ID, then you can have the product, and then you can have okay. Maybe lastly something like date created. So this is where now it gets databases gets powerful, because now database can connect different tables together, and now that's what we call now relationship. We have that's why we call them relational databases. We can relate this data to this data, because now we have now the order ID and then the customer ID, which is now fetched from now the customer's table. And then we have the product, then the what you call the amount for that specific product, then we have now the date created. Okay. So in that, let's say I have orders table. Every time someone buys something, we save it here. Okay. So first row we can have something like let me have something like order ID is 100, then the customer ID is 1, then we have now product is let's say something like laptop, then you can have is 30,000. Then if it's created, you can use today's date, which is 2026. So you just look at this. This is one record for orders. So order 100 was placed by customer, who is now John. Okay. So we have to see the connection. This order belongs now to John. The database knows the relationship because the IDs match. Okay. Now this ID match with this one. So the database knows about that relationship. So this is why databases are so powerful. Everything is connected and concurrent. Okay. And when you order food on an app, there is a customer's table with your information, an orders table with what you bought, a restaurant table, a delivery driver's table, all connected together. So you can have as many tables interconnected together. Okay. The database keeps a track of everything and shows the right information to the right people at the right time. So basically that's a database on current tables with rows. This is what we call now the rows, which is forms now a complete record, and then columns all connected together, just like a fill-in cabinet, but in for this one, for these databases are more powerful because of these interconnections and all that.